Hello and welcome back. This is kind of a improvised video because I didn't actually plan on making it, but the video with the other Robin printer and the print speed was really popular. I didn't expect that, and so this is the follow-on, and I'm trying to make the new Big Bad Robin print carriage, and I've mocked up everything that I've so far printed and built, and I think it's going together rather well. And I was just about to weigh the new setup and find out how heavy it's going to be, and I'm doing this right now. So this here's the entire new print head that I'm making, and I'm just putting it on here and to make sure that it sits on there. So I don't know if you can read this. Maybe I can get you a little closer. So it's 157 grams. That is that's pretty good, and it's around what I was expecting. This is for the total mass that will be put on the rail, so it will probably not be vibrating too much. And I actually changed a couple of things. So there will be a part that is in front of the rail and another part that is behind the rail, and that is going to improve the weight distribution, and it makes sure that that we get a little less vibration at the end of the rail, because every time we accelerate and brake this, we're actually putting a little bit of torque onto the rail. And since the rail is basically on a ball bearing on this side, it is going to flex or move a little bit, but we're trying to keep this down to, like, I don't know, 0.2 to maybe 0.5 millimeter, and with a nozzle size of 1 millimeter, I think it's 1 or 1.2 that I have in here right now, it's not going to make too much of a difference, I hope. I did change the setup quite a bit. And now have a fan on the back side too. So there will be two fans. One is the single fan for the extruder and the cooling of the print, and the second fan will run at the same speed as the front fan, but it will be just cooling the print. There's one forward of the print, one backward of the print, so as we're moving, it doesn't really matter in which direction we're moving, we will be getting the print anyway. So one is going to blow this direction, the other one is going to blow this direction. Regarding the rest of the setup, so back here you can still see the leftovers of the old extruder. That was the dirt cheap one that I modified or improved, and it's been holding on really well. And I've been using it up to now. That was also a pretty successful video, don't know why. So let's have a look at one of these extruders. Sorry about that, my camera just died. I like to use these EA1 extruders, and these kits are available at a pretty reasonable price, and they do come with a pretty good cooler. It's nicely machined, a good combination of heater cartridge and sensor. I've never had one of those fail on me, and I've used quite a lot of them. And of course it also comes with a bit of PTFE, but I like this a lot because they actually give you 6 nozzles in different sizes. Kind of hard to see here. And oops, one just went flying. And they give you 6 throats. And these are 5 throats with PTFE inserts. So let's see if I can get this open. So there's a tiny PTFE insert right in the center here, and this goes all the way up to the nozzle. And if you change your nozzle, you should also change this insert. That's why you get this many throats, because you can't really change this. And the upper PTFE, I can show this actually goes right into the throat, and it joins up. Well, this doesn't do it so good. So this actually goes in here, and there's this 2mm PTFE right in the center here. And I like these hot ends quite a lot, because they're reasonably priced. You get a lot for the money, and they work quite well. In a recent video, somebody claimed that the PTFE should never be touching the nozzle, and with modern hot ends, that's just wrong. All of the hot ends basically have a piece of the throat where there's a PTFE going right up to the nozzle, with one exception, and that's the one that's in here. There are so-called all-metal throats. Let's get this apart. And these all-metal parts, they actually have the metal sleeve all the way to the front. And if you're printing with something like nylon or even ABS in some cases, you want to use one of these throats. They do tend to have a little bit more of oozing, and they can be quite hard to clear up if they ever get clogged. But they're better for higher temperatures. And that one comment explicitly said that this was the case for E3D hot ends, and I do have one here, which is an E3D V6 Lite, and with them, with those hot ends, you get a much heavier cooler core, which is machined steel. But for them, they have a very large hole, and the PTFE goes all the way right into the heater block, and it actually touches the nozzle. So they're quite different. I do like the E3D hot ends, but they're a little bit too heavy for what I'm doing with my printers. But I've used a few of them in the past, and it's absolutely top-notch quality, of course. Okay, so with this one, you can see that I'm using a Volcano hot end, which has much larger nozzles and a much larger area where the filament gets heated up. Of course, that produces more oozing, and it can be a problem. It does not have to be, and you should just take that into account. The other thing is that because the heater block is so big, you only have a very small amount of space to get your heater block cables out, and you should account for that when you make a mount for this. So the mount must stop with the bottom of the cooler. The rail will be going through here, and this area down here is for the return of the belt. And I do have enough room so I can actually tie this cable up behind the second fan, and I don't think I will be having any problems there. If I do, I can still rotate this 90 degrees to the left, and I could just get the cable out this way. I don't know which way I want to go for this, but I suppose I will be doing it this way with the cable tucked underneath the extruder and the rail, and I'll fix it to the backside fan. So what else? Oh, I did of course modify the length of the sensor. So the sensor is way more down because the heat block is bigger. So I extended this tube and I made sure that everything fit in here, and I put this nut in here to get this tightened up and loosened, but then, well, the nut doesn't quite clear the distance between the mount to the rail and the extruder mount, so the nut will have to go, and I will just be clamping it with the little clamp that I have here, and that's gonna work fine. Right, so for this hot end I still need a few parts because I'm missing the little insert up here, and I don't know where that went. So usually you have one of those pressure air inserts, and this one just appears to be missing. And I had that problem a number of times where I got third-party extruders and cooler blocks that were missing parts. I don't know what's the issue with that, but I'll find something, or I'll just order it separately. Yeah, that's the whole extruder part, and I think it's pretty small. It's also pretty light. I think it will do well. Well, this is just the first release, and there might yet be some changes. Like, I have air inlets down here. I'm not sure if I'm going to just tape these up so they're closed. There is enough of an opening right in the back of here to pull in enough air to get this fan working, and of course the other fan will take its air through the cooling block of the heat block, and it will then just push it out the bottom, and it will be directly over the print. And apart from the fact that you need different software for that, it actually works really well, and it makes for a very light extruder. Yeah, so let's try and get this attached to that here, and then clean away the mess on the printer. Write up some software for the controller and see if it works. Easy. So step one of putting it together is, of course, taking it all back apart again. I'm going to have to shorten a lot of these screws, but I can't get the right size screws at the moment, obviously. I can't just go into a shop and buy this. Well, that's the whole holder part. It's held together with 4 screws at the back, and there's this little hole in the back that I think I'm going to tape that one off for now. Yeah, I'll probably use some aluminum tape for that, and that's just going to be closed. It doesn't actually need that much air. Yeah. Here's the hot end itself, and I'm just going to check what kind of a throat we have in here, and maybe I'll adjust the nozzle too. We have a PTFE throat, And I think I'm going to go grab a 0.8 millimeter nozzle for this and then finish putting it together. So here's my stash of leftover throats and nozzles. And it looks like we have some nozzles left here. .8. What else we got? 1.0. 0.8 or 1.0? Let's go for 1.0. It's not like we can't change it, it's just going to be really hard. So, of course, you know this, you want to drive the nozzle in exactly up till the end and then return it 1/2 turn so you can get it to seal with this top part, and you do not want to have it pressed against the heating block itself. And that way you can make sure that you can always grab the nozzle properly. And then you just give it a real good squeeze. So this is done now. As you can see, this just fits snugly in here. And the air comes in from the side. It needs to go once around the whole cooler and is then pulled out at the top. And the air can also go directly, but it doesn't really. And there are openings at the side here just to pull in a little bit more air to get the air tighter around the cooler. These coolers really do a great job. I have to get this out somehow, and it was a pain to get this into here. It's going to be a pain to get it back out. So this screw here needs to go, and this little hole here needs to be taped up. So for things like this, I usually use aluminium tape. It's pretty common with air conditioning and solar stuff, and it does a real good job. And it doesn't mind getting hot. Ooh. And that little patch will do fine. Well, that is the first part. And where was the second thing that we wanted to tape off? That was this thing. We'll get some more. this here is taped off too. Taped off, masked off, fine. Okay, so this here goes on first. And we can get this lined up while it's on the outside. Give it some tension. This is the mount, and that goes on here fine. So here's a bit of my design philosophy, and that worked out really well for me. Never make anything more complicated than it absolutely needs to be, and if you can, start simple. So as you could see, everything just kind of pops together, fits into each other, and all of the parts are as simple as they can be. All of the tie downs here are cable ties. It's simple, easy, light, and I'm pretty sure it's going to get complicated later on. But I'd rather make a simple extruder and write a little bit of simple software than make a really complicated extruder and forgo the writing of software, which I enjoy. And it just works out like that very well. Okay, so we've got the front mounted. Now I need to mount the back fan, and I may need to get a few more parts for that. Well, we'll see. Has any one of you ever assembled hi-fi components, and while leafing through the instructions you read, if you're on 220 volts you need to short something on the PCB before starting the build, especially before putting it together? Yeah, I had that moment too, twice. I just had everything bolted up nicely, and I realized I had forgotten to add a sensor to the heater block. And well, it took me about, I don't know, 45 minutes to get it somehow in there past all the other components down there and in this confined space. It would have probably taken about a quarter of an hour or 3/4 of an hour to take it all back apart, put it back together, and add the sensor, so no loss of time there. But then I realized this heater wire is going to a Volcano extruder, and I had no idea if this heater was 12 volt or 24 volt. So I just measured it like 2 minutes ago, and it checks out for a 12 volt variant, which is what this printer is. So I messed up once for the sensor wire, which I had to add while everything was already together. and I had a lot of luck with the heater cartridge being the right type. And then I was putting away this old extruder, and while getting it out of the way, I heard some kind of springy noise and some sort of clickety clack somewhere else in the room. And sure enough, the spring went missing. It's going to be a lot of fun looking for that one. Probably find it in a year or two, and by then I won't know where the rest of the extruder is. So yeah, that was extremely annoying, but everything else checks out. I don't have any play in this. Everything's bolted up. The extruder checks out. The temperature sensor checks out. I've got the two fans. I do not have the fan nozzles yet, but it's going to take some time to make these because I want to get it right. And apart from that, I think I have everything mechanically in the positions that I want to have it. I'm now going to have to start the wiring, and the wiring is going to be slightly more complicated because I want to move everything behind the post. Right now it's in front of the post, but that's not going to be too hard because it's just only one wire that I have to relocate, and the rest of them are going away anyway. And then I'm going to mount the extruder driver with a stepper to the back post. I think that's going to work out fine. But yeah, that was like really stupid, because I already went and got this sensor, so I was just lying there, probably screaming, "Don't forget me!" But I did. Okay, so next steps are going to be starting up the wiring, and then let's see if we can heat and cool this this extruder after applying the software fixes for having the fans running all the time. Yeah, it's gonna be a lot of fun. So continuing with the build effort, I thought maybe we'd have a look at the situation regarding the extruder driver. I went through my stash and I kind of found out that I only have one remaining TiVo Titan extruder, and I don't want to use that, so I think we'll be using this here. This is a kit that I got from Amazon, and it's an all-in-one kit, which consists of a real V6 Hotend with everything you need, and it includes a E3D, and not TiVo, it's an E3D Titan clone, and this one is really, really good, with one exception. There's one part in here that doesn't really fit. So first of all, it comes with a stepper, but I'm not going to use this stepper on this printer since I do want to push a lot of volume. I am going to be using a large NEMA 17 stepper. These are the stepper from Longs. I've been using these for years, and I really love them. They're extremely good quality. The only downside to these steppers is they come with rather short cables, and you have to extend them yourself, which for me is not so much of an issue, but you should know if you buy some of those. But the steppers themselves are absolutely excellent. So here we have the geared extruder. Everything, it's got bearings. It appears to be good material. Haven't had any cracks forming. It has the signature E3D groove pulley wheel. It works extremely well, and it has one of these V6 cooler fans, and it comes with a stepper mount that actually has 3 holes, and I needed to have 3 because I wanted to mount it in the middle of the 40mm rail. So these holes are the ones that I'm looking for. The one that I got from TiVo and from E3D only had 2 holes at the sides, so it wasn't quite as useful as this thing. And there's some tools, some Allen wrenches. I have so many of them now I don't even know what to do with them. And this thing has a feeder tube, and the feeder tube is absolutely perfect for 3mm filament. Well, there are 2 in there. One is for 3mm, the other is for 1.75mm. And the 1.75mm doesn't actually, well, it's kind of crooked when you put it in, and once the filament is pinched, it has to go through here at a slight angle. But I found out that if I put some PTFE instead of this feeder tube, it works really well, and I've not had any issue with it. So apart from this slight shortcoming, this is a pretty good extruder, and I think they're like 17 euros for the entire set, and at the time that was dirt cheap. So I'm going to try to use this one and try to put this together, and I think this will make for a really nice extruder driver with a Bowden tube, of course. Yeah, so let's try and put this together. So here's a nice bonus of this extruder. It even comes with a metal gear, and I like that. You just have to make sure that you put the metal gear in so that it's not riding on the rub screw. Okie dokie, so I was able to make the whole cable loom or the cable set together with the PTFE tube, and I had to lengthen some of the wires, I had to shorten others, but it's basically done now up to the point where I can start working with the electronics and with the heater and fan. The software's still not updated, and believe it or not, I had the extruder apart 2 other times because I was running into problems with the wiring, and I somehow managed to get one of the temperature probe wires in a knot with one of the other wires that I was trying to pull back. So that didn't go all too well. And if we look at the extruder now, it is still in the same state that it was before, but it is all nice and mounted. I've checked the tension on the belt. I've checked that the belt will move on the underside. It is touching, so maybe I need to make another holder for the axis so the belt moves a little bit further downwards. But right now I'm just going to let it rub on the carriage. It's not going to be too much of a problem. Apart from that, everything went kind of well, apart from my camera acting up and turning itself off a couple of times, but it seems to do some kind of intelligent editing of a boring video. So each and every time I start working and just leave the camera running, it's going to turn off after a few minutes. Well, what else did I do, and what do I need to do? I don't think there's much more to do on the extruder part, apart from making nozzles for the fans. And so I will be focusing on getting a new version of the firmware onto the printer right now. I had planned to redo the mount where all of the electronics is in, because it's just so flimsy over there, but I'll do that later. Also, I removed the existing extruder with this heavy stepper and everything, and I even found the little spring that had gone missing. It was waiting for me on the covers of my lathe, just waiting for me to pick it up. So luckily that is one of the things that I do not have to go look for. I did find out something, and I don't know what to make of it. This wire that is part of that stepper that I got has a non-standard color coding on the cables. I don't actually know if any of the phases are switched over or oriented in the wrong direction. That might have been the issue why I was losing steps on this extruder. I'll look into that if I get the chance, but for now it's going into storage. It has actually held up quite well. Maybe I'm going to heat it up once more just to be able to clean it a little bit. But this thing, after modding it and getting the cooling improved and everything, this here worked really nice. And it did do a lot of very long and material intensive prints for what it's worth. So yeah, I'm kind of happy with this one. The only downside of it is that it is so incredibly heavy. We can put this on a scale and just see what the difference is. So we know that the new extruder is 151 grams, and let's see what this one has. This one is 400 grams. Wow, 400. So we are literally saving quite a lot of weight on this. And it's just going to improve the quality overall. I don't know if the Bowden is going to be a big problem. I don't think so, because I have a large nozzle, and I'm using my A-grade PTFE tube. This one is from a shop that sells special gear for high pressure actuators, and this PTFE tube is rated to not be flexible, to not get longer when it has a lot of tension on it. And this was really expensive. I think 5 meters of this were like 45 euros, but I never use that much for one printer, so this printer has the longest piece of PTFE that I've ever used on a single printer. and it's held up for quite a while. And regarding the quality, it's a lot better than some of the cheap PTFE tube that you get with your cheap extruders. So that definitely is money well spent. Okay, so I'm gonna try to make the software, and then I'll try to turn it on and to bring you back then. So this is the first test print that I'm going to do, and it's basically just a random print. Let's see how it works out. Most of the settings are still way off, like for example the auto leveling. But it appears to be printing. And it's doing a nice job. I don't think this object is supposed to be that large. So there might be something wrong with the slicing in general. We'll see. Now I didn't have any cheap filament, so I want to keep the test prints low in number, because with a printer with a 1mm nozzle, I don't really want to use that much of filament at a time. Because this stuff that I'm using is fairly expensive, and we'll see how that works out. I just realized that I haven't even corrected the layer height, so it might as well be trying to print something in, I don't know, 0.4mm layer height or something like that. So no idea how this print is going to turn out, but it looks quite good right now. And you might be wondering why the printer is so silent. It actually has TMC drivers for the X and Y axis, and the stepper for the extruder or the Z axis doesn't need silent drivers. So this is turning out really nice. Wow. It's of course going really slow right now, but I am pretty happy with the fact that it's working at all, because this thing's been putting up so much of a fight. And I thought it might just really disassemble itself once I'm done, or I have a lot of vibration. But this post I have back here is basically just to make sure that I don't have so much, because if I have a lot of vibration, it's going to make a lot of noise, but it's not. And usually I only have a short post on here for transport purposes, just so I make sure that I don't run into anything or put too much stress on the x-axis. Yeah, this is nice. Yeah, the ventilation for the extruder cooler is very well. Yeah, it's actually pumping a fair amount of air out right now from both the fans. And this is just a slightly elevated fan level. I think it's at 50% right now. Sweet. Let's see if what was that? Whoa. Let's see if I can get you zoomed into this. Yeah, I'm actually printing with a ridiculously small layer height, but that's okay. Yeah, I sliced it with 0.2 millimeter layer height. Well, for a start, that's fine. So it looks like it's under extruding quite a bit. I'm going to raise the extruding level by, let's say, 25%. So I'm putting the flow multiplier in the firmware up to 125%. And let's see if we can get good flow in the infill then. So this is just eating up the filament. Okay, so let's stop this print. Let's zoom out again. No. Wait. Yeah, so let's stop this and remove it. This looked okay, but the layer heights are just, they're not what you want to use for a nozzle this big. So let's see if we can get this off. And then we'll try something with a 0.6 millimeter layer height. And that should prove a lot more interesting than this. Here we go. So here's the next print. So we just start a new one. So once again, it's heating up. It's going to do its little calibration dance, but that is just played wrong. Not even sure that I want to leave that enabled, but yeah, right now let's just leave it the way it is. And it's going to do the same print again, but it is going to take a layer height of 0.6 millimeters, and the first layer will be 0.5 millimeters. The rest of the settings are going to remain the same. Well, I think this filament has picked up a lot of water and it needs to go in the oven soon. But half an hour at about 60 to 65 degrees will make it work fine again. So first thing it's going to do is the brim, and I changed the settings for the brim to have a little bit more overlap. The entire first layer is going to have more overlap, so it gets a better chance at sticking down on the print bed. It's a good idea to do that. Now you can see that it is extruding a little bit too much filament here, which is just forming little hills where the print head is then skipping over, like over tracks of a record. But the next level should be high enough for it to just go over there. Yeah, that is a nice thick layer. And well, yeah, I kind of messed up there. So there's just one layer for the bottom, which is of course not enough. I'm gonna have to change that. The settings are actually not in layers, but in millimeters. So if I have 1.0 millimeters set, it is going to divide that by the number of layers that it needs to get to that height. So in this case, with 0.6 millimeters, the bottom layer is simply just one layer, which is not enough. Same goes for the walls. The walls are now too thin. I have just one single layer forming the walls. So this print is going to be really, really bad. At the same time, it's really interesting that it's working at all. Okay, I'm going to stop this print too, because I just increased the pressure on the filament on the extruder stepper, because the filament was slipping at the wheel, and yeah, that's of course not what we want. And I'm going to have to, well, work on the settings that I've got for the extruder, so we get a little bit more wall material. But it did come out very nice. So this is not what we want. It's also not bad. So the first layer is pretty much perfect, but then we can see that we had a lot of under extrusion, and that was where the filament was actually slipping in the driver. so no issue there. We can fix that. The rest doesn't look so bad, so we need at least 2 layers for top and bottom, maybe 3, but that would make it like 1.8 millimeters in height. So we have to set that in the slicer, and we can just try again.
This is the 3rd attempt at making a nice little box, and still fighting the settings a little bit, but I think I'm improving. From what I can tell right now, it was a lot, for the first print, it was a lot easier to get the brim off, so that only had a height of 0.2 millimeters, which for a brim appears to be a very good height. For the second print, it was 0.5 millimeters, it was very hard to get off. The first part was suffering from severe under extrusion, and I don't know if you can really see this, zoom in a little bit. So there are holes in here, and it was really suffering. The second one was a lot better, and you can actually feel that it is really, really hard, it's sturdy, and it won't bend or budge, while this here with all those holes in there, this really flexes. So I'm now trying to go for settings where I have more layers at the top and at the bottom than I would have with this one here. And at the same time, I want to have a greater wall thickness. So it's going to put a lot more material into the walls and into the bottom and top. And let's see how that one comes out. So this is going to be my last test for now, and then I'm going to look for something that I really need to print. What you can see now is that it is actually attempting to make 2 wall layers, and that should make for a much nicer outside. In case you're wondering, the setting for the infill in percent is 25. I think that might be a little bit too much, but it was a setting that I felt confident with from the start. Yeah, it's doing 2 bottom layers right now, so it's on the second layer. It is doing 2 layers for the wall, or it goes past the same area twice. And yeah, that appears to help it a lot. Yeah, I think this print is going to turn out pretty nice. And those prints are incredibly hard and solid. Well, it should be, there's so much material in there. I can just see it gobbling up from the spool.
So I like the way it does the outside layers and then builds on that. So it's now doing the first solid fill for the top, and it should do 3 of them, I think. But we can see that we're getting a lot of needle skipping on the surface. This will probably improve with cooling. I did let it run to the end this time because it looked quite okay. I think it's not perfect, but it's a lot better than what we started out with. We can see that it doesn't produce any infill for these little indents here, which I suppose it's okay because it's less than a millimeter. And the first layer is still very thick, but we can see that it basically filled up everything up to the walls with a few slight open holes in here. That might be under extrusion. I'll have to look into the settings and take some measurements. It might also be that the extruder is limited in the amount of steps it can go. I have to take a look at what the maximum speed for the extruder is. So we might be running into a limitation there, but that is configured very conservatively, and I can just make that faster. But the rest of the print looks very nice. The edges look nice. The infill and everything around it looks good. It sticks down really well. Come on. Pop off already. Here we go. So this is the first working sample print, and I must say at 0.6 millimeter layer height, I'm happy. It's not super, but it is respectable. So looking at what the slicer did, we can actually see that there are very big spaces around these posts, and the spacing itself is very broad, so it is actually using most of the 1 millimeter nozzle size that it has, and it doesn't plan with any overlap. So this is exactly what we're seeing in the results from the sample print. So the reproduction of what it was meant to print and the planning match up exactly. So that is very nice. That is really nice. So, well, with that, I'm going to finish the video for now. And, well, thanks for staying with me. And I hope I can continue on this in the future. Seems to be a really interesting project, especially trying to get the settings right. But wow, 1 millimeter nozzle size. Looks really good. Well, thanks for watching, and bye-bye.